Okay, so this is the setup for the to observe the triple point of liquid nitrogen. As you can see, this is the PNID, the piping and instrumentation diagram, along with a photograph of the setup. And this is the actual setup. You can see the bell jar. There is a small beaker inside where we'll be filling liquid nitrogen, the butterfly vacuum valve, the pressure gauge, and this is connected from the bottom. You can see this particular port, which is connected to a vacuum pump, to this bellow, to this rotary vane vacuum pump. Okay, so the other end is anyway sealed, so this is just dummy. So what we'll be doing is we'll be pouring liquid nitrogen into this beaker right here. There's an RTD which is connected here, an RTD PT100, so that goes through these two terminals and into a temperature controller where we'll be able to record the temperature. So we'll be observing the temperature drop as we reduce the pressure using the rotary vane vacuum pump. The pressure we'll observe on this gauge. Okay, so this is the beaker. Yeah, this is the beaker. I've just washed it and I've made sure that there's no moisture on it, because if there is moisture then it will start to frost on the sides and we won't be able to observe the phenomenon inside. So I've washed it and I've dried it. Okay, so I'm placing it in position. Okay, so beaker is in position. We have placed it on a small on the reel of a Teflon tape, that is to minimize the heat and leaks from the bottom. So now that is in position, I'm going to place the RTD. So the RTD PT100, that is also in position. So I'm going to pour liquid nitrogen into the beaker, and then as soon as that is done, we will seal it using a bell jar, and then we'll start the rotary vane vacuum pump. So I have liquid nitrogen with me here in this vessel, thermocol box. So initially, since the glass beaker is at room temperature, it's going to take some time for it to reach thermal equilibrium. So that's why you can observe that there is quite a lot of boil off initially. So we'll allow it to reach thermal equilibrium, leaving it some time, and I'll keep pouring it. Okay, so the beaker is filled with liquid nitrogen. I'm going to seal it up with the So bell jar is in position. Valve is closed at the side. This valve is closed right here. Pressure is showing atmospheric, and then we start our rotary vane vacuum pump. So you see the pressure is dropping. The temperature is also dropping. Okay, you can see that there is some, you can't say ice, but it is solid liquid nitrogen. You can see the initially the boil off which was there with the bubbles and all, that is not there anymore. So you can see one part there. So there is just a moment where all the three phases coexist in equilibrium. Uh, that is the triple point, and that occurs at a particular temperature and pressure. The temperature is close to 63.5 and the pressure is 0.125 bar atm. Yeah, so that is it. Yeah, so now I'm switching off the rotary vane vacuum pump. You can see it is still in the solid phase there. Of course I can't lift the bell jar because the pressure inside is still vacuum pressure below atmospheric. But as soon as I open the valve here, I'm allowing warm atmospheric air to enter. That will result in increasing the pressure, and the warm air will cause a phase change once again. So you just observe the cooker. So I am leaking gas into the system, I mean air into the system. Yeah, and you can observe there's a phase change all over again. Now I lift the beaker and there is liquid nitrogen inside. Okay, so what happened earlier was that because of the beaker shape, we could not observe all three phases coexisting in equilibrium. I have now taken a different vessel, glass petri dish kind of vessel, so that we can observe it better. So I'm pouring liquid nitrogen. Again, there's a high boil off right at the beginning. Okay, pressure coming up. I've already explained. Now I've changed the vessel. No, there is, see, you can see it is getting formed now. I mean, phase change is occurring. Temperature.
How the triple point will you observe? Without that, how will you say it is the triple point?
Phase change.
That is visible, but the temperature you have to show.
Temperature we will show in table corresponding to pressure. Pressure readings are given. Pressure is dropping. If you put liquid nitrogen and pressure is dropping, obviously temperature has to reduce.
And done. It's forming.
See, even here there is ice. Okay, that is ice. Take it.
It has formed.
But I want to observe all.